My name is Peter Thomas, and this is my extra credit project for Physics 1. In the project, the height of the arc is 140 feet or 42.67 meters. The length of the rope from the pivot to the bottom when the rope is fully stretched is 39.62 meters or 130 feet. The person, when he is at the bottom of the rope swing, is 10 feet above the ground or 3.05 meters above the ground. We assume the mass to be 75 kilograms. The first step is to find the speed of the jumper at the bottom of the swing. We use the energy fundamental principle for this. The initial kinetic energy is not needed because the initial velocity is equal to 0. The masses can all be cancelled. You then solve for final velocity and get 27.86 meters per second. You next solve for the tension at the bottom of the swing, which is equal to the force of gravity plus the centripetal force, which is mv squared over r, and you get 2,204.3 newtons. Next, we determine the speed of the jumper in the ideal rope 30 degrees from the bottom of the trajectory. To do this, we use simple trigonometry by doing cosine of 30 times the length of the rope. We then subtract this from the length of the rope and add the original height. And the new height is 8.35 meters. We then use the energy fundamental principle one more time, where our initial energy is when the person is at the bottom of the rope swing. We have all the values we need except for the final velocity at the 30 degrees from the bottom of the trajectory. We plug in our values and solve for the final velocity and get 25.93 meters per second. To determine the tension in the rope at 30 degrees from the bottom of the trajectory, we do the force of the gravity at 30 degrees, which is found by mg divided by cosine 30, plus the centripetal force, which is mv squared over r. We get 2,121.48 newtons. The next step is to find the stretch of the rope at the bottom of the swing. We do this by using a reputable source from rockclimbing.com and estimated to be about 10 feet or 3.05 meters. We then use this stretch and the force at the bottom of the swing to find the Ks. Then we take this Ks and the force at 30 degrees to find the stretch at 30 degrees, which is approximately 2.76 meters. This is the entire code for the extra credit swing project. The code is very similar to the spring lab. The rope is presented by a spring. To simulate the rope swing, the force of the air, the force of the spring, and the force of gravity are all accounted for as the jumper swings. The arrows shown represent the perpendicular and the parallel force. The swinging person is characterized by the green ball, the arc is characterized by the white ceiling, and the rope is characterized by the orange spring. The graphs show change in momentum and change in position over time. The jumper is shown to be moving with the greatest speed right after 5 seconds. The tension is greatest in the rope when the person is at the bottom of the swing, which is characterized by the largest arrow. My computational predictions and my analytical predictions are pretty similar, as I use some of my analytical predictions in my computations. And that's all for my extra credit project. Thanks for watching. I hope you enjoyed.